and we can inference it either, or we can go for fine tuning with our use case. So basically, so what is fine tuning? We'll see that to the legend is we'll see what is fine tuning, what is the difference between the pre-trained model and the fine tuned model, what is actually the pre-training, and what are the limitations, what are the advantages, and how do we prepare the data set for the fine tuning, what are the different approaches for fine tuning, and after fine tuning we see we are not satisfied with the accuracy, then we'll see how we can improve the accuracy and how we can make it more robust. Okay, so starting with what is fine tuning. Basically, fine tuning is something, the thing is like we alter the model's parameter. We see there are a lot of LLM models available, right? See, this is the Hugging Face platform. Here we have a lot of models, right? We can search for the Llama model, and so these are the models available. We can directly take them and we can do fine tuning for our use case. Okay, so in the fine tuning, we have two techniques. Mainly one is changing the parameters of the model and other one is without changing the parameters. So we'll see the simplest methods of fine tuning, like without changing the parameters. Okay, so in without changing the parameters, we have three techniques. One is zero shot learning, few shot learning, or one shot learning. So coming to the zero, one, or few shot learning. So basically, the thing is, this is also known as in context learning. I'll also show the demo. I mean, the coding part, how we can do that one also. For every technique, I'll show the coding part as well. So coming to the zero shot learning, here simply we take the model in the prompt itself. We provide some examples, right, for the model in the prompt. That is called something in context learning. In context learning, we have zero shot, few shot, or one shot. Zero shot means simply the name suggests that in the prompt, we do not give any example related to the task, right? We just give the system prompt and we tell the model that this is the use case and the user will be asking the questions or the queries to the model. The model will be responding the responses, right? And in one shot, we just provide the one example. And in the few shot, we just provide more than one example, like 2, 3, anything. So basically, this is 0, 1, and few shot learning. So I'll show the coding part also, like you can see here, right? I have downloaded the libraries like Transformers and Optimum and AutoGPTQ. These are my required libraries to run the LLM model. And from the Hugging Face itself, I have taken the model called Llama. Okay, we have taken this model, and now I have loaded the model here, Llama 2 7-bit chart, and I'll tell you what is this GPTQ. Let's keep this aside now. These are called quantizations. I'll also discuss that what is the quantization also, right? We have taken the model and I have loaded the model, and you see here in the prompt template I have given such that you're a helpful, respectful, honest. Something I have given the prompt. This is simple, a plain English. You can talk with the model that I'm also giving instruction that your answer should not cause any harmful, unethical, and racist, toxic, dangerous, or illegal. And I have given this prompt. And if you do not know how to answer the question, please do not share false information. I'm just telling that model, if you know the answer to the question, you just respond yes, or else you just respond, I do not know, right? So I'm just, these 4 lines of code for the inference. See, now I have given the question in the prompt itself only, right? Tell me about large language models. And I have passed this prompt to my system prompt, right? And I'm loading the model, inferencing, and it has given me the response, right? See, this is the question. Tell me about the large language models, and it has given the response. Large language models such as transformer based models are artificial, and it has given 4 to 5 points immediately, right? So if you could observe here, I haven't done anything. if you focus on this part, right? In the prompt template, I just given the default prompt as an instruction that you will be so and so, and you will be guiding the user so and so, and I'm just given the question, right? I haven't tell the model like this is the way you should generate the response, or this is the way you should answer the question. I just given the system prompt. I have given the prompt, and it has generated the response, right? But if we see the same in context learning with examples, same, I have taken the model, I have loaded it. And in the prompt template, if you see, I have changed the prompt. See, generate the response that incorporates the provided context, question, answer. I'm giving one example. Like this is the context. Context is something population. So in 1880, it is something 45%. In 2013 to 1970, like this, I have given the context. And I have given one question: how many people lived in that town as of 2000? And I'm telling the model itself, right, that your answer should be like, as of census 2000, there was 1382 people and 472 households, like this. And also I have given another context, right? For example, say this is example, I mean the context one example, and I have given another context like similarly, and I have given question in how many league appearances he had scored 10 goals. Then your answer should be like this. Then now in my prompt third, I have what I have done is I have put one empty context question and answer. Right. Now what I'm doing now outside the prompt template, see here the prompt template closes, and outside the prompt template, what I'm doing is I have passing the context, right? Movie and its director, movie name Titanic, and it's James Cameron. It is in English language, right? And like this, I have given. And in the question, I have given in which year did the Titanic movie release, right? So I have passed this context in question. I have combined with my existing prompt template, the this in context prompt template, this one, right? I'm passing these two, and I'm again inferencing the model. And if you could see, it has generated the response. Titanic was released in 1997. Right. This is called in context learning. Here, if it is very easy task such that we are just taking the existing LLM models, I mean the large language models, and we are just providing an context, right? If we do not provide this, it becomes zero shot. Like here, what you are seeing. If I provide some examples, right? Like one example or one shot or two shot, then it becomes few shot learning. This is called these are the examples for in context learning, right? Also you can see there is one more example for in context learning where I have provided, see, I have taken one prompt template which is called capital context. I have given Paris, France, New Delhi, India. If you see, this is the capital, this is the country. So Moscow, Russia, and I have left blank space as London, and I have closed the prompt, and I'm passing the prompt to the model, and I'm asking to generate the result. I mean, complete the prompt I'm saying. So what it says, like, see, it has given London, United Kingdom, and few examples like Beijing, China, Tokyo, Japan, like this, right? So now you may get doubt, Pascal, like how, sir, like how is this possible? How will the model know that the what the user wants? It is because the models are pre-trained. We all know that the LLM models are pre-trained, right? The LLM models have been trained on a large corpus of text for billions of pages. I mean, C4 corpus and on internet data for some years, right? And based on that, whatever the task we want, we can easily do, right? With its pre-training knowledge. We did not touch the parameters of the model. We just providing the context, and we just providing the examples, and we asking the model to identify the pattern and generate the response, right? This is called in context of learning. This is without updating the parameters. Now coming to the other part, which is called updating the parameters, right? In updating the parameters, here comes fine tuning, right? What is fine tuning? What we actually do in fine tuning is, it's nothing but fine tuning is nothing but tweaking the model's parameters, nothing but changing the model's parameters such that making it suitable to perform a specific task. Getting it? So we just take the model, we just fine tune it with our specific data. It means how, again, you may get doubt like how do we fine tune? What is the process like? There will, because large languages models are, you could see like there's some if see, they are heavy in size. They're around 9.9, around 10 GB that plus 3. These are called model shards. It means the entire model cannot be stored. So that's why while uploading it to the GitHub, they make it as shards and they upload to the, sorry, in the Hugging Face. Uh, Precisely, Hugging Face is called like something GitHub of models, right? So So we fine tune it. So we take the model, we make it suitable for tasks like sentimental analysis, text generation, or finding document similarity. Okay. Okay. So what does fine tuning actually do for the model? So what fine tuning actually does is, you see in pre-training, basically what we do is, um, we what happens means uh, the model will be generating the responses. For example, if we open ChatGPT and if I ask something like, I have a cancer, please refer me a doctor nearby Bhimavaram. I asked, yeah, if you see, I have given a prompt like something like, I have a cancer, please refer me a doctor near Bhimavaram. So what it does is, it has given the results, right? I'm sorry, Dr. Krishna Chaitanya, Dr. KV Krishnamani, and Sangita. But how can we trust this? It means whether is it the reliable data we are getting, or is it the pre-trained knowledge the response is coming from? So basically, for example, if we take, for example, consider our college, your college, like which is SRKR Engineering College. For example, if you want a chatbot for your students, like if your students wants to interact with the chatbot, with a live chatbot, like if somebody wants to know like what are the courses being offered, or what are the achievements of the college, something like that, then is it possible that for example, let's ask here only. So it is giving responses, right? uh, Based on the results, we can see it has NAC accreditation, research and development, placements, and computations. It is giving. Okay, but if something like if the persons or the students wanted to know more specifically, like what is the strength, or which courses are offered by which faculty, or what are the the tech areas or the research centers present in a college, so in detail, we cannot get, right? In that cases, what we can do is we can take the existing LLM model, we can take the data regarding our, the college or the institution or particular organization. We can fine tune the model, right? We can fine tune the model. See, we are taking the LLM. We can take the domain specific. For example, assume this domain specific data set as the task we want to do. For example, be it a sentimental analysis, be it a bank chatbot, or the organization chatbot, or medical chatbot. We just fine tune it, and the user will be giving the queries and the model will be giving the responses. Since we have fine tuned with our custom data, we have a trust in the data, right? We know that the responses we are getting are reliable. We can trust those responses. It means the accuracy part is somewhat good, right? We'll see how we can, I mean, um, do this fine tuning. I also show a demo like how that where by using the existing models, how we can fine tune that. Okay. So what happens means, so when we do the fine tuning, the first and foremost advantage is the hallucinations in the responses will be reduced. Hallucinations means something if like, as I told you, like when we go for GPT and we ask something more specifically like uh, in-depth questions regarding a specific domain or a specific organization, we do not know whether they're reliable or not. What model will think is, always the LLM generates the response based on the probability prediction, right? It will always try to predict the word that has the highest probability. It do not care about like whether it is giving the real or the correct responses or not. It always try. Its job is to predict the words based on the probability and to complete the response. To complete the prompt. That's what sometimes what happens means in the responses, lot of hallucinations will be coming, right? So with fine tuning, we can eliminate them, those hallucinations. And in pre-training, say, for example, it is trained on some Wikipedia or the Google data, it might not know anything about the a particular use case. Like, for example, if you want to do for a chatbot for a hospital, um, see, the hospital management has some uh, three gynecologists named so and so XYZ, and three cardiologists and two oncologists something. And if we go and ask the GPT, existing GPT, do not know like in detail about the hospital or the management and the work being done or the staff, etc. So we can prepare a data set of those organization. We can take that and we can fine tune the LLM and we can deploy it in the hospital website or somewhere. So what happens means whenever the patients or any will become, they will giving the prompt to the to the chatbot that I have so and so disease. Whom do I need to contact? So the based on its training, the model will be giving response. So based on your disease, you need to contact person X. His cabin number is this. His room number is this. From timings and appointment like that. But so that's why we use fine tuning mostly to deal with the domain specific data. The domain specific tasks. So what are the libraries basically we use for fine tuning? For fine tuning, basically we use call like something. There are many libraries. We go for PEFT fine tuning and LoRa, QLoRa, some techniques in PEFT, and mostly free and open source. We use like PEFT, Accelerate, Optimum, right? These are the from the Hugging Face. These are available in Hugging Face itself. For fine tuning, we can use them, right? Yeah, if you see in pictorial representation of fine tuning, you see this is the large corpus of text data scrapped from internet. Say it is a Wikipedia or Google data. We are taking the base LLM, right? For example, let's consider we know that the chart GPT has arrived. Is came in the picture on 2021 or 2022 year, right? But basically, it's the background GPT 3.5 Turbo is been there since from long ago, like 2019, 18, 17. Because the first research paper that is attention is all you need is presented in 2017. It contains the architecture for this. We are using the LLMs, transformer models and all. So they have taken the GPT, they have trained it and they have done a fine tuning with the domain specific data and they have obtained this ChatGPT. I'm taking one example and I'm saying similarly you can take the base LLM which is pre-trained on previously during its uh, pre-training only the LLM model is trained with the whole internet data. Now to this pre-training it has learned something from its pre-training knowledge. We are taking the domain specific data set of the corresponding task we need to do, and then we need to obtain the fine-tuned LLM. And to this fine-tuned LLM, the user will be giving the queries and we will be getting the responses, right? So now you some people may have doubt like what is the difference between pre-trained model and fine-tuned model? Because we have already done pre-training here, then why do we again need to fine-tune here? Because in pre-training, no data, pre-trained model, no data gets stored. In pre-training, what happens means only the model will be learn the patterns present in it, right? And also, like there will be whenever after the pre-training, when we start inferencing the model, there will be a lot of hallucinations coming in the responses, and it basically works through the RAG approach. You know, the RAG is something like retrieval. It means augmented generation. It works through RAG approach. But in fine tuning, what we have done is we have taken the domain specific data, right? And of course it uses RAG too, but not more, right? It means it is kind of the principle is RAG, but what happens means we only take the data, we only make the context, we only make the questions, and we only make the responses during the pre-training, I mean during the fine-tuning, and we train the model, we change the model's parameters, and such that we will be converting the model in such a way that it will be learning new things, right? And then more quality, I mean it will be learning the new information, and it will in the fine tuning, what happens means whatever the previous misinformation it has learned, now it will be able to correct with that information, right? So how this happens means how this training the model to learn text happens means we know that basically what happens means every time the model will be making if we take the sentences or the data sets, every time the model try to predict the labels, right? By using its self-supervised learning. What happens is, for example, I'm taking here, I am a data scientist, right? This is an example. The model will be creating its own label data set, right, from the sentence. Like for example, for the text I, the label will be am, and for IM, the next word which need to be predicted or which need to be predicted is a. If it takes I am here, the next word which need to be predicted is data. I am here data means the next word need to be predicted is scientist. Every time the model predicts the token by token, right? Every time. Okay. So in this way, for example, if you could see, um, here only you can see, like I have given the question. So what happens means every time the model is generating the words, I mean they're generating the response token by token. It do not generate the response as a whole. It means, for example, if I say, what is the capital of India? It means if you look at this prompt now, like what happens means this capital word is predicted using its preceding context, right? For example, this capital word is being predicted using this preceding words or the left context, usually we say, and then of India. It means what we are trying to predict, like here India, or it means whenever we have given here, what is the capital of? See, we are getting Philippines, Netherlands, like that. It means these all words are predicted, which are in bold. These all words are predicted only using the left context, right? In this way, the LLM model generate the response. Okay, always using the left context. So what are the limitations of pre-trained model? Why do we actually fine tuning? I already told you, because contextual understanding will not be there for the LLM model without the fine tuning. It may generate the misinformation and hallucinations. So by fine tuning our own LLM, what happens means we can increase the performance, right? In what way we can decrease the hallucinations? There will be the consistency in the responses generated, and also we can reduce the unwanted information. and also lower latency, and no breaches will be there in the data, right? And we have a greater control in the responses. Like in what way, in whichever way the user is interested, in that way he can train the, I mean, fine tune the LLM model to generate the responses. Okay. So what is the impact of fine tuning on the model? Why do we actually fine tune? In the sense, because I mean, how it will be impacting is if we take the models at two aspects. One is it's the model's behavior and the model's knowledge part. While fine tuning, we can able to overlap. I mean, we can integrate the both the changes into one model. Behavioral change means in the model will be generating the responses more consistently, and we can make the model as more conversational and also better at generating the responses. Right. In knowledge aspect, as you know, right, it is pre-trained. We are feeding the new data to the model. Right. For I'll take one general example and I'll tell you. Like if you consider a school boy who is studying class 10. So what happens means up to his class 10, he has studied from first class to 10th class, and he has some knowledge. Now suddenly, if we give one of the class 11 or class 12 problem or question to him, he says like he do not know, but his job is to give answer. So what he will do is he uses his 10th class or up to class 10 knowledge. He tries to generate some of the other response, but we are not interested in that. So what we can do is at that time we take we take the boy, or I mean the model. Consider the boy as, I mean the student as the LLM model. We take the student and we take the 11th class syllabus or the 11th class class 11 textbooks or some data, and we feed him, right? We feed him, and now if we are able, we could answer asks the question on something class 11 subject on thermodynamics or something, then he could able to generate the response, right? In this way, the fine tuning happens, right? So in till now, I have told you like without updating the parameters, right? That in context learning, we have zero shot, one shot, and few shot. With the updating parameters, we have two techniques. One is um, going for the full fine tuning, and another one is going for PEFT fine tuning, which is nothing but parameter efficient fine tuning, right? So also we have one more. This is very small concept called instruction fine tuning. Instruction fine tuning is nothing but is something like we take the data set, we we take the data set and we just create some instructions to the model, like so and so. um, for example, if we, for example, let's say if we want to automate the SMS chatbot, right? For example, whoever is using such a so and so network, after his balance, I mean after his recharge completes, we do not want to sit and we do not want to send messages to each and everyone, right? We want to make a chatbot such that it should be able to identify the users who has reached their limit, and it should able to send the SMS automatically, right? For that, what we do, we prepare an instruction like so and so. I mean, dear user, and your expiry has been, it, I mean, in 2 days. So you need to recharge like that. We have prepared some instructions, and we ask the model to like that. We prepare some 4 to 5 instructions kind of thing. We feed those instructions to the LLM, and the LLM able to generate the responses, and it will able to send the SMSs, right? This is what something known as instruction fine tuning. Okay. So for fine tuning, data selection is the most important thing. And how we can say like the data we have selected, it is like better or worse. Better, how we can say means the data should be higher quality and it should be diverse in nature, right? For example, if we are performing sentiment analysis task, we should not take the data consisting of all positives or all negatives. We should take the data such that that involves positive, negative, semi-positive, semi-negative, neutral, such thing. That the diversity should be there in the data, right? And more of also the if it is a real data, like real world data, then it would be the learning will be very, very good. And also we should take the more data, because since the LLM models are trained on, they have been trained on large corpus of data. For fine tuning, if we are using very, very small data set, there will be very little effect on the parameters. Right, the model cannot be able to identify the patterns, hidden patterns or hidden context that much very clearly. So that's why we need to take somewhat more data. Obviously, the worst data, like the opposite of this higher quality, lower quality homogeneity, it means if we take only one kind of data, and if it is a generated data, it means instead of we are using the real world data, if we are using somewhat generated by some models or machines, then that would not be really worth it for fine tuning. Okay. So this is very much important. Now here comes approach to fine tuning. How do we fine tune the models, right? First, these are the steps involved in fine tuning the large language models. I'll also show you a demo on the coding part as well. And also I'll show you an example, like what we can do so that you also can work on your projects kind of thing. So approach to fine tuning. So we'll see, like the first step is we need to find out our task, what we're doing, whether that may be sentimental analysis or classification task or the data separation or the image separation. Prediction or kind of the task. We need to figure out the task and we need to collect the data related to our task. We need to prepare because in fine tuning, I told we only provide the context, input, and answers, right? And we train the model, and then we start asking the models with, start testing the model with new questions and answers. And whatever the we need to collect the data, and we need to choose the model what we are. We need to go to the Hugging Face, and if in the Hugging Face, if we want to perform text generation tasks. In tasks, we have a lot of tasks here, like image classification, image segmentation, image to image, like question answering. If I want question answering, I'll click on this. You can see like these are a lot of models have there are a lot of models available. In these models, we choose one of the model for fine tuning, right? And we also take, we take the model and we load it to the, in Colab or where we want to fine tuning into the platform. And then what we'll do is we fine tune the model. We prepare the data set, we fine tune it, and we evaluate the model performance, right? Based on the performance, we check, are we satisfied with the results? If no, then we need to change the data, or we need to change the model, or we need to increase the task complexity. Or also, if the model is not performing well, then we go for the higher size, higher another model, right? And in this way, these are the steps involved. Okay. So now coming to the parameter efficient fine tuning. What is this? As I told you, right, in fine tuning, we have two techniques. In fine tuning, we have two techniques. One is without updating the parameters. This is something called as in context learning, which involves zero shot, one shot, few shot, right? I also show you examples. Now, with updating the parameters. So here we have something like two techniques, which is for full fine tuning and PEFT fine tuning. What is this PEFT means? Parameter efficient fine tuning, right? I'll tell you what is this full fine tuning and what is this parameter efficient fine tuning. So full fine tuning means we take the complete model, right? The existing, the base LLM model. We update the each and every model layer, and we fine tune it, right? So you may ask doubt like basically Bhaskar, like the model are quite heavy size. How much time it takes? Um, so basically the thing is, if I'll give you an example. Recently we have got something model known as Llama 3, right? I think you are aware of it, right? Even the WhatsApp has been deployed with the Meta chatbot. Meta has released this Llama 3 model. Sorry. So this Llama 3 model has been released by Meta. See this one. So if you, where I was calculating one day, I was thinking like how much time would take if I fine tune, if I go for full fine tuning this model with having, if you could see, like 70 billion parameter model it is, right? So if you could see, I was calculating that time it takes means in somewhere if we start around fine, if you go for full fine tuning this Llama model, if we start it in 2020's mid-April, then we would nearly end up in 2024 August by supplying uh, enough amount of GPU and enough amount of memory, right? So basically in industries, no one will go for full fine tuning. Most of the people or the most of the companies prefer to only go for soft fine tuning, which is only updating the subset of parameters instead of updating each and every parameters, right? Basically, are you able to, you're getting right? What happens means in in full fine tuning we cannot take the model or we cannot load the entire model into the system, and we cannot provide a power supply, or it also there should be continuous power supply 24 by 7, and also the GPU should be very huge, and also the memory to train that 70 billion parameters model should be very more. So that's why most of the people, what they do is they just go for parameter efficient fine tuning instead of going for full fine tuning. So in parameter efficient fine tuning, what is this parameter efficient fine tuning is? Nothing but something like, if we see, consider this as one of the layers in the model, right? In the model, we know that the LLM is completely something, it is the code, right? Python code. It is not something a black box kind of thing, right? It contains the layers, and each and every layer has weights assigned to it, right? In we know, no, right? Some weights and biases will be there for each and every layer. And in that, if we consider 13 billion parameters model, some weights were frozen and some weights we can modify. I mean, we can change those weights. So by altering only some those subset of weights, what happens means we can train the LLM model. I mean, fine tune the LLM model, not train. We can fine tune the LLM model only by changing those subset of weights. Okay, getting. So I'll also, I mean, if you see, like um, you may, what is this subset of fine tuning is? Consider this as a 3 cross 3 matrix, right? This 3 cross 3 matrix has some weights assigned to it, right? So what happens means this 3 cross 3 matrix is stored in such a way that here during the fine tuning, instead of we are obtaining every weight, we are just only changing the some weights, right? For example, 7 3 6 8 like that. So there is this technique. What it will do is, anyway I have obtained only some weights, I will only store those weights, and also instead of storing this entire 3 cross 3 matrix, I'll go for choosing I mean, I will go for decomposition of this matrix such that my storage space will be decreased. I do not need to store this entire 3 cross 3 matrix. If you see, if I store this entire 3 cross 3 matrix in such a way like that, in 3 cross 1 or 1 cross 3, my space is saved. Also, if I multiply, I mean, if I open this matrix, I mean, this 3 cross 1 into 1 cross 3, I will be getting again this 3 cross 3 matrix. I hope you are getting it is somewhat high level of understanding. I mean, just try to understand. Instead of storing this 3 cross 3 entire matrix, this matrix will be stored in such a way that it will be get stored using decomposition of matrix. You may ask doubt like how can we obtain this 3 cross 1 or 1 cross 3? How it will know? It is obtained based on using the rank method, right? Decomposition of matrix takes place using the rank method. It calculates the rank of this matrix, every weight matrix, and based on that rank, the matrices will be stored. And once they get open up during inferencing, they will be converting again into 3 cross 3 matrix, right? See. So in this parameter efficient fine tuning, we have LoRa and QLoRa. LoRa is what is that? LoRa is low rank adaptation. Low rank adaptation means the large weight matrix is divided into two smaller matrix by factorization method or something rank method, right? Instead of storing the large weight matrix, it will be just storing the smaller matrix. In this way, what happens means the kind of mean the size of the matrix will be decreased. I'll show you an example. Wait. If you see here, see, I'm taking the Llama 2 model, original Llama 2 model. Llama 2 model. See, if you see what happens means here the size will be something like 9 point around 10 plus 3 plus sorry it has started downloading. Yeah. So around 9 plus 3 something around 12, right? Kind of 12 GB are there. So so if our system or if our server do not have that much enough space or memory, then what we can do is we want the smaller size of this model. So what basically people do is they will try to reduce this. I mean, they will try to decrease the size of this model by using this parameter fine tuning. They will use this technique called LoRa or QLoRa. I will tell what is QLoRa. If you understand LoRa well, that it is QLoRa is something quantized. I will also tell what is quantized. Just we'll first try to understand what is LoRa. So they use this PEFT fine tuning. They will use this technique called LoRa and they will convert it into smaller model. So for this one, no, like the quantized version will be there, which will be of around. If you go into the model tree, no, model card, here we can see quantizations. 60 models are there. The same 7B model. This is the same 7B model. If you go to its files and versions, now you could see it is 4 GB. See, from somewhere 12 GB to 4 GB. It means it is compressed nearly 3 times, right? So this way it happens. So you may ask like, Bhaskar, like, sir, like, do we do do we need to do these quantizations or any pre-quantized models are available in the Hugging Face? Of course, there are a lot of pre-quantized models available, right? Also, if we are not interested in those quantizations, we also can take the base or original raw model and we can do the PEFT fine tuning with LoRa and we can also convert into a quantized fine tuning model, right? So this is what the LoRa. I'll show the code how we can use this. I mean, just understand this technique. The technique is just we reduce the size of the matrix by converting into smaller weights. I mean, smaller matrices. This is LoRa. Now, if we, yeah, some. Hello, any doubt? Hello.
You can continue.
Yeah, okay. So basically, the larger weight matrix is stored into two smaller matrices. In this way, the coefficients or the size of the matrices decreases. So coming to this quantization, QLORA, in PEFT fine tuning, here what we are doing, I told you, like instead of updating the each and every weight in full fine tuning, in full fine tuning, each and every weight gets updated. In parameter efficient fine tuning, only the last layers or the last layers of the model gets trained with the dataset what we are taking, right? You're understanding. Only the last few layers. In those few layers also, only the some weights we are tweaking. Kind of we are changing the weights to adapt to the new task that we want to perform, right? This is LoRa. And if it is quantized LoRa, QLoRa is something nothing but it is much smaller size than LoRa. If I should say, you know that in LLMs, in original LLMs, so weights will be stored in bits, right? In everywhere, even in computers, it means it can only understand the digits. So in full precision mode, so weights will be stored in full precision, which is FP32 bits. This is called, it means for storing a weight, we have 32 bits, right? Just imagine. These are not actually 32 bits. Just imagine this will be something 32 bits, like 1, 0, like that. It will be storing the weights in FP32 bit. So in this original model, so to store all those weights, that's why we have it is 7 billion parameters model, right? So that's why this much huge size model it is coming, like around 12 GB, 10 GB. But if the same weights, if we store it in smaller bits, like I mean, instead of 32, if we store it in FP16, which is called as half precision, right? It means instead of 32 bits, we are just taking 16 bits and we are storing. Right. So here the number of bits reduced. It means also the size of the matrix also gets reduced. If we use 8 bits, we can also store and we can also use 8 bits. Right. And also we can use 4 bits. Right. It means from 32 bits, we can obtain different sizes like 16 bits weights, 8 bits, and 4 bits. Right. Getting? So these are called quantizations. Right. So these are called quantizations. Like the 4 bit is called, like it is very less in size. It means from 32 bit size, we have converted the model to store weights in 4 bits. So below this, it is not possible, right? So basically the thing is, in general terms, if I should explain what is quantization means, mm, let's take one generalized real world example. If we consider a mobile phone, something which is older version, it do not have much memory or the speed of the mobile phone, right? For example, if we go for Play Store and if we want to download the Instagram into our mobile phone, Instagram app, in Play Store, the size of the Instagram app will be something around 70 or 65 MB, right? So we load it into the mobile phone. But what if our mobile phone is do not contain much enough space? Mobile phone is getting hanged because of its lower version. Much old phone. Then people will prefer the same Instagram. The experience with Instagram Lite, right? There is also an Instagram Lite, which is much smaller in size than the original app. Like it is around 7 or 8 MB. From 62 MB to 7 MB, they are getting. In a similar way, from full precision to we are getting the models into availability in much smaller sizes for the industrial usage, right? So this is what is called quantization, right? So to explain, to be precise, what I'm saying is, so in quantization involves converting high precision floating bit coefficients to lower precision, such as 4-bit integers. Right. For instance, 32-bit floating point number can be represented as 14-bit 4-bit integer with a range. Specific range will be there, right, for every type. So this is what fine tuning. Now I'll go through the coding part, and I will show you a demo. And also I will tell you in the Hugging Face what are the different this quantizations or the fine tuning methods. So this is I'm taking the Llama 2 model. I'm fine tuning. So let me connect my charger. Give me 1 second. So we'll see the coding part, how we can fine tune. We'll take one data set and we can. I'll also tell Hugging Face about Hugging Face. So these are the packages required like accelerate, PEFT fine tuning, and bits and bytes and transformers library. And I'm importing all the required libraries from the packages, right? So every model has a particular prompt template, right? I showed in the in context learning also I showed you, right? Here I am giving instruction, and from in the instruction I am combining my system prompt as well as the actual user prompt, and I'm closing the instruction, right? This is similarly, since I'm using the same model, I'm using the same system prompt, right? These are the some links I have kept. If I'll also share these documents, if anybody required, they can refer these, right? So I'm using the same model like Llama 2 7B chart, Hugging Face version, and I'm using this data set. And this data set is available on Hugging Face only. So these are the data sets. So it has these strings. The instruction, can you write a short introduction about the relevance of the term monosoap in economics? And it has given, and it also has the responses like monosoapy refers to the market structure, right? Like this, I have the data set and I'm using this data set, right? I'm taking this data set and I'm fine tuning. So as I told you, like um, I'm using the LoRa attention dimension 64, and this dropper, these are the parameters. And the like you may ask, the writing coding part is very easy. So everything we need to know is the background, how it is being done, like the fine tuning or the model parameters, how it is being changed, right? And I'm using an NF4 quantization. If I'm converting them to the floating 4-bit. And for storing my outputs, I'm creating one directory called results directory. And I have mentioned the batch size and my learning rate scheduler. I'm using the cosine function. I'm loading everything. See, I have splitted my dataset into loaded the dataset and split it into train and test. So this is the important thing class called bits and bytes config. This bits and byte config is used right to fine tune in during the fine tuning the LLM model. We combine our the floating bits and our quantization config here only. So then we are using the same tokenizer. I'm also using the Llama tokenizer, right? And I have mentioned kept the training parameters like output directory and number of training epochs and batch size and floating point 16 bit and also and now the SFTT supervised fine tuning trainer. This one I am using and I'm starting my training the model. I have initialized this class and passed the model, my training data, my configuration, right? My fine tuning configuration, the training arguments that I have taken tokenizer, and then trainer.train will start the training the model, right? So once the training is done, I am saving my trained model here only. I mean, this new model in the sense I have given initialized it here. I have just it's in a directory yeah here. This is the fine tuned model I am using, right? So once that is done, I'm saying, and I'm asking the question again, right? Now inferencing, what is the large language model? And I have used the pipeline and I have print the result. I mean, inference in the model. It has given that a large language model is an artificial intelligence model that is trained on and so and so. If you see, without fine tuning, in I have asked the same question. Tell me about the large language model. So what is large language model? It has given one response. Large language model such as transform based models, AI models, something generated. But with fine tuning, the response is much accurate. I mean, I would say like that it is very much relevant or precise, right? So this is the advantage of fine tuning. Like with fine tuning, what we can do is we can somewhat make the responses biased in nature. That means if you are performing a specific task, then what we can do is we can uh, uh, we can take that corresponding data set and we can train. And now I'm deleting all my empty, I mean, trainer and everything. I'm just getting collected. I'm storing my new model. And also there is Hugging Face as a liberty that whatever the fine-tuned model we have done, we can also push into the Hugging Face. Similarly, like a GitHub, whatever the project we have done, we have uploaded to the GitHub. Similarly, here also, whatever the we have done, we just upload it to the Hugging Face, right? So in this way, we can fine-tune the LLMs. Now, now I'll also take you through a demo, like so. If you could see here, Yeah. So I'm starting. So I am starting the LLM model. So now I'm asking the question to the LLM model, right? Mm, right. So I'm opening my Postman. You are no Postman, right? I'm just giving one question to the LLM model. I'm sending post request. Yeah. So I have fine-tuned an LLM model with the something called as MiSaver data, which is uh, OBC certificate or passport or document verification, right? So what happens means I have fine-tuned an LLM model and I have started running it in the background. You can see it is running on this 5000 colon, I mean port number. Now I start inferencing the model. I have given the input, how can I obtain OBC certificate? Once I have it here, you can see the model will be start generating the responses, right? See, if you could see to obtain OBC certificate in Telangana, since I have taken that, working on Telangana, so I have taken the Telangana state dataset, I mean the MISAV dataset, and I have taken and trained it. I mean fine-tuned the model. Now you can see like it is giving something very accurate responses, like log into the citizen portal using a Telangana app and me server services, you will be having the OBC certificate from the list of services, and you need to upload the required documents and call like ration card, Aadhaar card, Epic card, and property particulars, and pay the service charge of 45, and using the available payment modes and submit the the application. You will officer will be verify. This may take 45 working days. It means I have used the data set. I mean, if I same thing, if I ask to a GPT, I do not know like whether it will be giving the response or not. Also, I don't know like it will be giving that much accurate the response is, right? That's why fine tuning makes easy task that we take the data set, we take the model and we fine tune it and we can obtain the results. If you're not satisfied with the results, we can, I mean, go for increasing the complexity in the data or changing the model, right? So this was fine tuning, and I'll just tell you about the Hugging Face, right? What is this? How we can go for this quantized models and all. Right. Yeah. So we can see here in Hugging Face, we have a lot of models, right? So we have different tasks like object detection, text to image, image to text. If I want to perform something like document question answering, I'll click on this. I could see like layout, document, QA, right? These are the different models available. If we click on this, we can, if we go to the files and versions, we can see the model size. These are very small size models. It's around say half GB, like 500 MB. We do not need any quantization. We can directly load these onto the CPU and we can run. But if we take some quite heavy size models like 7 billion parameters models or 3 billion parameters models, we definitely require GPU, and also we cannot able to run it on CPU. Sometimes the server also gets crashed because it could not handle such heavy models, right? So I told you, right? Now there is a remedy for this. Like if so, like if I do not want to compromise accuracy. I want to use the somewhat the big size models, but I do not have resources. What is the solution? The simple way is you can go for quantized models, right? I told you like Llama 2 7B Hugging Face. I mean, it has around 12 GB, but in Hugging Face, the users what they will be doing is they will be doing the quantizations of every model, right? What is this quantization? I told you, right? Conversion from 32-bit to different sizes. So and also, do we necessary, are there any pre-quantized models available? I mean, post-quantized models available means, yes, they are available. And those different quantizations include GPTQ, GGUF, and AWQ. These are the different quantization techniques. This is also called as GGMN, but this is deprecated version, right? So these are the post-training quantizations available. It means we do not need to do this. Already there are some users have done the quantizations for us and they have kept the models inside the Hugging Face. We can take this. But what is the use of these three? What is the difference or the use in these three quantizations? Means GPTQ is something completely the GPU based. It means if you see here, while I was loading the model, it is GPTQ model, right? Yeah, Llama 2 7B GPTQ. So to load or run this model, I definitely need the GPU. So that's why I'm using the T4 GPU here. So I need to connect to this T4 GPU, and then only I could able to infer this model. So if I do not have the GPU, right? If I do not have the GPU or VRAM, and I only have CPU, then what you can do is instead of loading the full model, you can go for GGUF model, right? So GGUF is something which is CPU biased based model. It means it does not care about the GPU and anything. It only tries to load the models on completely on CPU. Only the layers which are quite having a bit more weight, I mean important, those only particular say around 10% of the layers will be loaded into the GPU. Rest every layer will be loaded into the CPU itself. And coming to AWQ quantization. So AWQ is something like it is the newly quantized technique when arriving nowadays. It is something how it has been useful is the model tries to predict that not all layers are useful, right? Some layers have less weights and less priority. Only the layers which have less priority, they will be skipped off. I mean, they will be uh, dropped down, and the layers which are more priority, more useful, they only gets used for inference. In such way, this AWQ quantization is useful. If you see here in Hugging Face, if I type the llama, I mean this llama. See, here we will be having GPTQ. See, here we have GPTQ. This is called GPTQ model. The bloke NSQL. The bloke is one of the famous user who will do quantizations of every model, right? And he has done GPTQ. He has made available for all of us these different quantized models, right? Also, we have GGUF. Similarly, we have AWQ. Right. If you look at the size, no, like the see it is around 4 GB, but the original model which we are using is, if you remember, it is 12 GB. So this is the advantage of this quantization technique. We reduce the size. And some people may ask doubt like, if you reduce the size, is there a guarantee that the accuracy part decreases? Exactly. The quantization research paper also says that there is a drop in the accuracy, but that is merely around. It depends upon the model to model. Like if from from float 32 to if we are using 16-bit, there is something around 2% or 2 points decrease in the accuracy. If we are going for the much lesser quantization, say 4-bit, then there is around say 9. If it is the original model accuracy is 92%, then if you go for the 4-bit quantization, it will be around something 86 to 85% the accuracy. So if we are okay with that accuracy drop, then we can go for different quantization models, right? So for the one original model, we can also find in mean. Here, if you go to the model tree here, then we can see for this original model, people have made 60 models quantizations available for us. So if you click on this, we can see these all are the quantized models. I mean, quantized versions of the original model. We can use like this. Getting. So this is the advantage of quantization. So I hope I could able to help. So there are still 10 more minutes. I would like to answer your queries if anyone's having any doubts. Like, hello.
Hello,
Hello.
sir.
Yes.
Yeah,
Yes.
just a minute.
So there is a query in the chat box that what are the fine-tuning parameters in LLM model?
Let me open. What are the fine tuning parameters in LLM model? So basically, LLM model consists of different parameters, right? We have uh, 7 billion parameters models. We have 3 billion. We have 2 billion, right? So fine tuning parameter in fine tuning we change the model parameters, right? It means there is model consists of number of layers. Every layer has parameters. There is no specifically like these are only the use, these parameters are used for fine tuning, these are not for fine tuning. Every layer has parameters, we can use them for fine tuning. And also while we are fine tuning, we do not know which layers we are obtaining. I mean, the modifying. We just only know that we are trying to modify the last layers or the middle layers. I mean, some subset of layers in the LLM model. But we do not know like we are obtaining the 10th layer or we are obtaining the 12th layer. That specifically we do not know. During the training, fine tuning, we just only try to change the parameters.
Okay, sir. Thank you. Thank you very much. If you have anybody are having queries, sir will answer within 1 minute. Otherwise, he can leave the session.
So uh, I think all are okay with it. So thank you everyone for giving me this opportunity for the coordinators as well as for the management. Thank you very much for.
Thank you, sir. Thank you very much. You are given very good insight about the fine-tuning data sets and the techniques. That is very useful for our research purpose. Thank you. Thank you very much, sir. So,
Yeah.
dear participants, the next session will be start within 5 minutes. The next session will be from the prompt engineering and fine tuning methods will be taken by Aruna Kollu. So, from USA, within 2 more minutes, she will be joining. Thank you, sir. Thank you, Bhaskar sir. You can leave now.
Yeah. Thank you.